Welcome to the Padhai Karlo JEE preparation channel. Welcome to the Padhai Karlo JEE preparation channel. Practice more problems on this exact topic on our Padhai Karlo Android app below or on our website padhaikarlo.com. Today's topic is the energy stored in a capacitor and the three equivalent formulas used to find it. Let's begin. Charging a capacitor genuinely requires doing work, since each additional bit of charge must be pushed onto the plates against the repulsion against the ripper, though simply Q times V, because the voltage itself keeps rising continuously as charge builds up. Integrating this rising voltage over the entire charging process genuinely gives the total energy stored, U, equals half QV, exactly half of what you'd naively expect from QV alone. This factor or 1/2 is genuinely the single most important thing to remember about capacitor energy. U capacitance, C equals Q over P acting muk Philadelphia nes Philadelphia Philadelphia Poronda 1, Philippi Sahoy Indonesia. Two other completely equivalent forms, U equals half CV squared, or U equals half Q squared over C, and all three forms genuinely describe the exact same stored energy. Each of these three genuinely equivalent formulas is most convenient in a specific situation, depending on exactly which two quantities a problem actually gives you directly. If a problem genuinely gives you capacitance and voltage, use U equals half CV squared directly. This is genuinely the most commonly used form since C and V are the two quantities most often specified in JEE problems. If a problem instead genuinely gives you charge and capacitance, use U equals half Q squared over C instead, and this second form is genuinely especially useful in problems where charge stays constant like an isolated, charged capacitor, since Q squared over C then directly tracks how energy changes, as capacitance itself is varied. Choosing the algebraically simplest form for the given information genuinely saves significant substitution work. The single most frequent involves genuinely distinct constant when a capacitor's parameters change. If a charged capacitor is genuinely isolated, disconnected from any battery, then its charge Q stays constant. As you change something else, like inserting a dielectric or moving the plates, so you should genuinely use U equals half Q squared over C for that specific case. But if the capacitor genuinely stays connected to a battery throughout, then it's the voltage V that stays constant instead, held fixed by the battery, so you should genuinely use U equals half CV squared instead. A frequently tested numerical trap involves genuinely computing the energy density, the energy stored per unit volume between the plates, given by half epsilon naught E squared, where E is the electric field. This specific formula is genuinely worth memorizing separately since it appears constantly in JEE electrostatics problems. Let's recap. The energy stored in a capacitor is U equals half QV, with three equivalent forms half CV squared and half Q squared over C, depending on which quantities are given. The key distinction that trips up most students is isolated versus connected. An isolated capacitor keeps its charge constant, while a battery-connected capacitor keeps its voltage constant, and choosing the matching formula is essential. Pareshi release avar pi avarti vandi palvai sharak vandi pi vaya vandai crew half E ski squared, rounds out and appear across electrostatics problems. That's the energy stored in a capacitor. Keep the isolated versus connected distinction sharp. It's the fastest way to pick the right formula and avoid the most common trap on this topic. If this video helped, please like it and subscribe to Padhai Karlo for more JEE preparation content just like this. See you in the next one.